Hey guys, Mr. B here, and in this video we're going to be going over the practice problems in chapter 1.2 on a scientific approach. Alright, let's start off with number 1, identify the goal of any scientific method. So this is one of the main ideas in the notes, and of anything I guess in this section it's probably the biggest thing to take away. But the goal of any scientific method is pretty much to solve a problem or gain knowledge about something we didn't know about beforehand. Okay, so you can put down the goal. Let's make sure this isn't bolded. The goal of any scientific method is to solve a problem or gain knowledge. Okay, something like that. Oh, that's fine. All right. Number 2, name 3 types of variables in an experiment. All right, so we did talk about 3 types of variables in this section. They were, these are directly from the notes, by the way. They were the manipulated variable. That's the variable that we change. There's the responding variable. That's the variable that we are measuring after we've changed something. Then there's controlled variable. That's the variable that doesn't change throughout the entire experiment. Okay, so we have manipulated. We have manipulated variable, responding variable, and controlled variable. I guess we'll go variables, plural variables. There we go. Let's see if we can shift this up maybe just a smidgen. There we go. Let's turn that back red. There you go. We're losing some space here. Okay. Number 3, it says true or false. If the data from an experiment does not support your hypothesis, you can revise the hypothesis or propose a new one. Yeah, totally true. If you have data that doesn't back up what your initial idea was, by all means, you should revise it. You should come up with a new idea or new hypothesis and basically try again, right? Do a different experiment, try it again. So. All right, number 4, how does a scientific theory differ from a hypothesis? Okay, so this is one of the bigger ideas in the section where a lot of students have some big misconceptions about the words of theory, law, hypothesis. So remember, the difference between a theory and a hypothesis is that a hypothesis is an idea about what you think is going to happen. Whether it's a good idea or a bad idea or a really educated idea or like a really well backed up idea, it's still an idea. A theory, on the other hand, is an explanation about why something does the thing it does. Okay? A theory is not an idea. It's not a really, really well tested, educated idea. And it's an idea I have about something, but like it's a really good one because like I really know what I'm talking about and I backed it up with, well, no, it's not an idea. A theory is an explanation. Okay, if it's an idea, it's a hypothesis. So we're basically going to say a theory is an explanation about how something works. A hypothesis is an idea about how something works. Okay, doesn't matter how good an idea or how bad, it's a hypothesis. Okay, theories are not hypotheses, they're not guesses, they're not ideas, they're explanations. If you have a theory, you already know how something works. Okay, you've tested it enough times, you know exactly how it works, then you can make a theory. So, number 5, what is an observation? An observation is typically something that we make with our senses. So obviously our senses are touch, taste, smell, sight, hearing. Whether we use our own senses like our own eyes or we use a machine that can see stuff for us, it's still something that we gather with our senses. So you can say an observation is information that we gain through our senses. There you go. All right. Moving on. Number 6, true or false, a scientific law attempts to explain an observed pattern in nature. That is false. Okay, remember that scientific laws do not explain anything. Scientific laws will just tell you this is what you're going to see. Why? Don't care. Okay, theories attempt to explain what you see. So theories are explanation, but not laws. So this is false. Okay, this is false. Number 7, all scientists may accept a given scientific law, but different scientists may have different blank to explain it. All right, so this is basically saying all scientists may accept that a certain law exists and like this will happen, right? So for example, let's just take the law of gravity. All scientists will accept that gravity is, or that gravity exists. You drop a ball and, you know, it causes things to fall and whatever. But there may be different theories to explain how gravity works. So one scientist might go, well, my explanation is that gravity is a force and it pulls things downwards. Another scientist might go, no, my explanation is that the ground actually rises up to meet things so that it's not falling, it's actually the ground's coming upwards. Another scientist might have a theory that explains how gravity is gravitational waves that like warp space and time and cause things to like bend inwards. And again, all of these things have to be well tested and backed up. So I understand that maybe one of the examples I used there might have seemed a little far-fetched and it might have sounded like a hypothesis. All of these, of course, would have to be able to be backed up with evidence and lots of tests. But either way, a lot of scientists may have different explanations. And gravity is actually a pretty complicated thing. So you might think you know a lot about gravity, but I can guarantee you probably don't know nearly as much as you think you do. So there are different theories about how gravity works. Okay, number 8. Why do scientists use scientific models? So remember that models are basically just simpler versions of real things. And models are useful because they help us visualize things that we may have a hard time visualizing or observing ourselves. Okay, so you can say scientists use scientific models to help make observations that are too difficult to make on their own. All right, last question, number 9. Circle the letters that correctly state what scientists do if data show that a model is wrong. So which of these can we do if our model is wrong? Change the model. Yep, 100%. No doubt. Yep, if your model's wrong, you can change it. Replace the model. Totally. If your model's wrong, yeah, replace it with a better one that's not wrong, right? Or that's correct. C, ignore the data. No, you definitely cannot just ignore it and go, I don't want to pay attention to that because it doesn't back up what I want to see, so I'm just going to ignore it. No. Or D, revise the data. So you go in there and you just change it yourself. You just like, I don't like that number. It doesn't really work well, so I'm just going to change it to a 7. No, you can't do that either, okay? So if your model is wrong, then you can change the model or you can revise it to a better one. But you can't just play with the data to make it fit your whatever you want it to do. So, all right. Anyway, that was it for this one. Pretty short, but hopefully that helps. So, if you have any other questions, again, as always, feel free to email me, reach out to me, talk to me in class, or we can always do Google Meet or something. So, all right, guys, I'm Mr. B, and I'll see you in the next one. Bye.